Hi, hi, hi. I'm sorry. That was an infinite loop, and fortunately, we could quit it. Today, we're going to talk about recursions, infinite loops, and so on, and how to make the process to be continuous to do the same thing several times, but with just a little bit of code. Okay, great. Okay, let's imagine a situation when you go to a cafe with your 5 friends and you need 6 burgers because all of you are very hungry. However, the waiter is not that much strong and he can bring only 1 burger per time. Okay, that means that he should serve you 6 times to bring 6 burgers. Okay, do you need to kind of call him, say that you want a burger, and then he will go, and then you can call him, say that you need another burger? Actually, yes, but you can just say, okay, I need 6 burgers, and each time he brings 1, says that, okay, there is 1, still needed 5, okay, brings another, still needed 4, then still needed 3, and so on. Then he will see that, okay, 6 burgers are brought, okay, I'm done, I can go. That is what we call recursion in functions, in programming, and today we're going to know how it looks like in JavaScript. Let's go on. The simplest and the most appropriate to explain this amazing topic is the factorial, because it includes all the idea that this concept includes, and I hope that you will understand the whole picture of this topic, the recursion, after this example. Okay, what I'm going to talk about is this. Yes, factorial. In case you don't know what is it, don't worry. Factorial is a mathematical function, we can say, that counts all the numbers before the product of all the previous numbers. For example, 7 factorial will be equal to times the previous one, so times 6, and then times 5, times 4, 3, 2, 1. And you got it. 7 factorial is equal to this. Okay, but what if you want to count 12 factorial or 20 factorial? Should you count it by hand like this? Like, even with a calculator, I don't know, 20 times 19 times 18? No, really no, if you are a programmer. Okay, this is a great scenario when we have a great assistant every day with us, and that is our computer. So if you are a programmer, you are the one that knows how to talk to computers, or you want to learn how to talk to them and use them, benefit from them. So this is the case when you will benefit really. Okay, the function we will call, quite simple, factorial. And okay, let's see. We can count factorials for numbers that are greater than 0, so positive, and I think there is no sense to count the factorial of 0. So our function should stop somewhere, because if you don't stop it, it will do the same activity continuously, which will cause an infinite loop, which will do boom. Your computer will maybe break down, maybe you will not be able to talk to him, maybe you will break up, and again, don't do that, never. Be attentive, don't do don't write a code that can cause an infinite loop. There is no sense. Okay, if you want to break something, do it. Yeah, I support you, do it, but I don't think that you are a devil, or I don't know, so you will better not. To start with, maybe each time, the function will be this. Okay, calm down if you don't understand. The function has maybe 3 main parts. Yeah, I would say. The first one is when we declare a function, we say const factorial. Yeah, very simple. We call our factorial that counts the factorial just factorial, because everyone will understand what this function does, right? Yeah. Okay. After that, into the curly braces, we write what the function should do. In its turn, the function has 2 main parts. Termination part that stops the function to prevent from being it an infinite loop, and the part that makes it recursive, makes it do it again, and several times. So okay, the other part is called recursive. It's the part that makes the function do it again, and then again, several times, as much as needed. Got it? Okay, let's explain. What is factorial, you already know. So you could have guessed that numbers should be positive, because the time when you do times 0, everything that you have done before is becoming 0. Nonsense. Really, nonsense. So you should prevent the code to do that. Never do times 0 after the whole calculation, because you can just write 0 and do nothing. So the function or the number that is going down continuously, decreases, should never be 0. It should decrease till 0. So if it is equal or smaller than 0, because we don't want to count the factorial of negative numbers, I don't want to that, because it's not mathematical. So smaller than 0 or equal to 0. This is the case when the function should stop. So to say it stop, we say return what? Nothing. No, nothing. So just stop. That's the way how we stop it. Here you can say you can see the part that makes it recursive. So what you see is n. N is the number that you put in the function to count the factorial of that number. So n times 1 before. For that, we should do n minus 1, right? Yeah. So why don't we do just n times n minus 1? Because we don't know what the number is. Maybe n is 100 and n minus 1 is 99. And what we should do the other 98 numbers too. So that's why we never do something that we don't know. So we should not play with the variables, because they are variables, are famous. Okay, so that's why we call the function again. We say, okay, whatever the n minus 1 is, do whatever the n is, do minus 1. If n is 20, it becomes 19. Yes, yeah. Okay, and then again, it's already 20 times 19 times whatever it is, do minus 1 again. So it calls the function, and again, now already 18 times, and so on, until it's becoming a great number that I don't know what. But you can know that just calling this function. I think that's all, and I don't want to go much into detail, but it's a very interesting topic. I really like it. So if you have any questions, you can comment it, and I will be glad to help you. And maybe it's too difficult to try to find a great solution together. Okay, thank you. This was the recursion class. Enjoy it. I will meet you next, I hope.